Question 1. In the context of material takeoffs, Mr. Ramirez is tasked with estimating ductwork lengths for a commercial HVAC system. The blueprints show multiple transitions and offsets that complicate the linear measurements. Which method should Mr. Ramirez use to ensure the most accurate duct length estimate that accounts for all fittings and changes in direction? A. Measure only the straight sections shown on the blueprints and add a fixed percentage for fittings. B. Use the scale on the blueprints to measure duct center lines, including all transitions and offsets. C. Count the number of fittings and multiply by an average length for each fitting, ignoring the straight duct runs. D. Use standard duct length tables based on system type without measuring the drawings. Answer. Correct answer. B. Explanation. The most precise approach for estimating duct lengths in complex layouts involves measuring along the duct center lines on scaled blueprints, including all transitions and offsets. This method captures real-world duct runs and fitting locations, minimizing errors common in simply adding percentages or ignoring straight runs. Option A is less accurate because applying fixed percentages is a rough estimate and often underestimates actual lengths. Option C neglects straight duct sections and leads to incomplete calculations. Option D disregards project specifics and can cause large inaccuracies. Using scaled centerline measurements aligns with best practices in HVAC estimating to reflect actual material needs accurately. Question 2. Which of the following best describes how psychrometric properties impact the sizing of HVAC equipment in a humid climate, as Mr. Patel considers for a new hospital project? A. Psychrometric properties mainly affect only the heating load calculations, not cooling. B. Humidity levels impact latent heat loads, which influence the cooling capacity required. C. Psychrometrics are secondary to ventilation rates and do not affect equipment sizing. D. High humidity decreases the sensible heat load and thus reduces equipment size. Answer. Correct answer. D. Explanation. Humidity significantly affect HVAC load calculations, especially in humid climates. High humidity reduces the sensible heat load because latent heat moisture removal takes precedence. Thus, the cooling equipment must be sized to handle latent loads, often requiring larger or specialized systems for moisture control. Option A is incorrect, as psychrometric properties are crucial for cooling loads due to moisture. Option B partially explains latent load but neglects the reduction in sensible heat, which affects overall sizing. Option C is inaccurate because psychrometrics directly impact equipment selection and sizing. Understanding these concepts ensures appropriate load calculation and equipment specification. Question 3. When analyzing the impact of ventilation requirements on HVAC system design for a school auditorium, Lee notices that increasing outside air to meet standards leads to high energy costs. What is the best approach for balancing code compliance with energy efficiency? A. Decrease ventilation rates below code to save energy. B. Use energy recovery ventilators ERVs to precondition incoming air. C. Reduce indoor occupancy to lower ventilation demand. D. Use only recirculated air to minimize outdoor air intake. Answer. Correct answer. C. Explanation. Indoor occupancy directly influences ventilation rates as per ASHRAE and local codes, so reducing occupant density reduces required outdoor air volumes and thus energy consumption. This approach balances compliance with energy efficiency while maintaining indoor air quality. Option A violates code and is unsafe. Option B is a good energy-saving method but may not always be feasible or cost-effective, and the question asks for the best approach balancing compliance and energy costs. Option D compromises air quality and fails code compliance. Choosing occupancy control reflects practical strategies in HVAC estimation and design. Question 4. During the process of selecting HVAC equipment for a large office building, Mr. Thompson finds two units with similar capacity but different SEER ratings. Which principle should guide his equipment choice? A. Always choose the unit with the highest SEER rating regardless of cost. B. Choose the unit with the lowest upfront cost to minimize capital expenditure. C. Balance SEER rating with life cycle costs including energy consumption and maintenance. D. SEER rating is only important for residential systems, so ignore it for commercial buildings. Answer. Correct answer. D. Explanation. SEER seasonal energy efficiency ratio primarily applies to residential air conditioning equipment. Commercial systems typically use EAR or EAR ratings that better reflect operational efficiency under varying load conditions. Option A ignores cost-benefit analysis. Option B overlooks operating costs that often outweigh initial costs. Option C is a good general principle but misapplied here since SEER does not accurately measure commercial unit efficiency. Understanding proper efficiency metrics avoids errors in equipment selection and leads to accurate cost estimating. Question 5. Kim is reviewing a bid for HVAC installation that includes a large number of custom fabricated sheet metal parts. Considering industry best practices, what should Kim carefully evaluate to ensure accurate cost estimation? A. Only the cost of raw sheet metal material. B. Fabrication complexity, labor hours, and material waste allowances. C. Price per pound of sheet metal ignoring fabrication steps. D. The warranty offered by the fabricator as the primary cost factor. Answer. Correct answer. B. Explanation. Accurate estimation of sheet metal parts requires consideration of fabrication complexity, labor costs, and waste allowance. Custom pieces require more labor and can generate more scrap, increasing costs beyond raw material price. Option A neglects labor and overhead. Option C ignores fabrication and waste factors, risking underestimation. Option D is important for quality but not the main factor in cost estimating. Properly factoring all these elements aligns with sound estimating practices, leading to comprehensive and reliable bids. Question 6. Given the circumstances of a multifamily residential retrofit, Garcia needs to calculate the heating load using manual J procedures. She notes that the building has significant air infiltration. How should infiltration be treated in the heating load calculation? A. Ignore infiltration because it is accounted for in the building envelope values. B. Add infiltration as a separate load based on estimated air changes per hour and temperature difference. C. Include infiltration in the ventilation rate only. D. Assume infiltration is negligible in retrofit scenarios. Answer. Correct answer. A. Explanation. Manual J typically incorporates infiltration within the building envelope characteristics or treats it as part of ventilation loads but does not require separate infiltration loads if already accounted for. Option B may cause double counting. Option C limits infiltration to ventilation, which is incorrect because infiltration includes uncontrolled air leakage. Option D is unsafe because infiltration can be significant. Proper understanding of manual J procedures prevents over or underestimating heating loads in retrofit projects. Question 7. While examining a project specification, Nguyen discovers a requirement for hydronic system design including specific pressure drops in the piping circuit. How should this impact the estimator's approach to material takeoff and equipment selection? A. Ignore pressure drop requirements as they do not affect material quantities. B. Select pipe sizes and pump capacity to meet pressure drop requirements influencing cost and labor. C. Use standard pipe sizes regardless of pressure drop to simplify estimation. D. Pressure drop requirements only affect the commissioning phase, not estimation. Answer. Correct answer. B. Explanation. Pressure drop is critical in hydronic system design, directly influencing pipe sizing, pump selection, and labor. Oversized pipes increase material costs. Undersized pipes cause performance issues. Ignoring pressure drop risks inaccurate estimates and system failure. Option A disregards key design factors. Option C oversimplifies and may lead to inefficient systems. Option D ignores early design and cost impacts. Correctly factoring pressure drops ensures realistic cost and equipment estimations. Question 8. Considering the evidence from recent studies on refrigeration cycles, Cooper needs to select a refrigerant for a system prioritizing environmental impact and efficiency. Which principle should guide her selection? A. Choose the refrigerant with the lowest initial cost regardless debut or efficiency. B. Select refrigerants with low global warming potential debut and high thermodynamic efficiency. C. Use traditional refrigerants with known performance, ignoring environmental factors. D. Select refrigerants based solely on compatibility with existing compressors. Answer. Correct answer, C. Explanation. While environmental impact is important, established refrigerants with known performance and compatibility often provide more reliable and cost-effective solutions. New ditto refrigerants may require system redesigns and may lack proven long-term efficiency. Option A neglects environmental concerns. B is ideal but may not be practical in all scenarios. Option D overlooks environmental and efficiency factors. Balancing proven performance with environmental considerations is essential in estimating and selecting refrigerants. Question 9. To what extent does the integration of energy recovery ventilators (ERVs) influence the bid strategy for commercial HVAC projects? As Estimator plans his proposal, they ERVs increase upfront costs but reduce operating costs, requiring lifecycle cost analysis. B. ERVs always reduce total project costs and should be included in all bids. C. ERVs complicate bid preparation and are generally avoided to simplify proposals. ERVs have minimal impact on cost and can be excluded from detailed analysis. Answer. Correct answer, A. Explanation. Including ERVs raises initial equipment and installation costs but provides significant energy savings over the project life cycle. A thorough bid strategy weighs these upfront costs against long-term benefits, enabling competitive and profitable proposals. Option B incorrectly assumes universal cost reduction. Option C ignores strategic benefits and may lose competitive advantage. Option D underestimates ERV impact. Accurate lifecycle cost analysis is crucial for advanced bid preparation. Question 10. From a practical standpoint, Mr. Daniels is tasked with estimating labor costs for a complex rooftop HVAC unit replacement. The project involves restricted access and multiple subcontractors. How should labor estimating account for these conditions? A. Use standard labor hours without adjustment to maintain consistency. B. Increase labor hours to include additional time for access challenges and coordination. C. Only add contingency percentages at the end of the estimate. D. Assume subcontractors will handle access issues independently and do not adjust hours. Answer. Correct answer, D. Explanation. Estimators should proactively adjust labor hours to reflect site-specific challenges such as restricted access and multi-subcontractor coordination. Ignoring these leads to underestimated costs and project delays. Option A fails to reflect reality. Option B is good practice but should be detailed rather than a vague increase. Option C treats contingencies too generally. Option D wrongly assumes subcontractors absorb difficulties without cost implications. Accurately estimating labor fosters realistic bids and project planning. Question 11. During the process of reviewing mechanical drawings for a large retail center, Johnson notices inconsistent symbol usage for diffusers across different floors. How should she best approach ensuring accurate quantity takeoffs for these diffusers? A. Assume all diffusers are the same type and size based on the most common symbol. B. Cross-reference the legend carefully for each floor to identify exact diffuser types and sizes. C. Use an average count of diffusers per floor and multiply by the number of floors. D. Contact the architect to request revised drawings without symbols. Answer. Correct answer, B. Explanation. Accurate quantity takeoffs rely on understanding the exact equipment specified. Cross-referencing the legend per floor ensures correct identification of diffuser types and sizes, preventing costly estimation errors. Option A oversimplifies and risks inaccuracies. Option C assumes uniformity where there may be none, causing wrong quantities. Option D is inefficient and may delay the estimate. Proper legend review aligns with best estimating practices, ensuring precision in material and cost forecasts. Question 12. Which of the following best explains why estimating refrigerant piping insulation thickness is critical in preventing energy losses in chilled water systems as Estimator evaluates project requirements? A. Insulation thickness does not impact energy losses but only protects the piping from damage. B. Adequate insulation thickness reduces heat gain, preserving system efficiency and preventing condensation. C. Thicker insulation always increases system cost without any operational benefit. D. Refrigerant piping should never be insulated in chilled water systems to allow heat dissipation. Answer. Correct answer, D. Explanation. In chilled water systems, refrigerant piping generally requires insulation to prevent condensation and heat gain, preserving efficiency. Option A ignores energy efficiency impacts. Option B correctly identifies the role of insulation in reducing heat gain and condensation, crucial for system performance and longevity. Option C misinterprets the cost-benefit relationship. Proper insulation balances cost and operational savings. Option D is incorrect. Lack of insulation leads to inefficiency and potential moisture problems, contradicting best practices. Question 13. Collins is sizing a new rooftop unit based on cooling load calculations that include window solar heat gain. Which factor most significantly influences accurate load estimation for this component? A. The color and reflectivity solar heat gain coefficient of the window glazing. B. The number of occupants in the building. C. The type of HVAC equipment chosen. D. The orientation of the building's roof. Answer. Correct answer. A. Explanation. Window solar heat gain depends largely on glazing properties like color and solar heat gain coefficient AGC. These characteristics determine how much solar radiation enters the building, affecting cooling load calculations. Occupant count. B. Influences internal loads, not solar gain. Equipment type. C. Does not affect load calculations, but system response. Roof orientation. D. Influences solar exposure but is less direct than glazing properties. Accurate load estimation requires detailed glazing data for precision. Question 14. Under the assumption that duct leakage is significant in an older commercial building, is Nguyen must factor this into her cost estimate for system renovation. How should she account for duct leakage? A. Ignore duct leakage as it is covered under system inefficiencies. B. Include costs for sealing ducts and potential duct replacement or reinforcement. C. Factor duct leakages. A percentage increase in energy costs only, not in material costs. D. Replace the entire duct system regardless of leakage severity. Answer. Correct answer. C. Explanation. Duct leakage affects energy efficiency and operating costs, often resulting in higher utility bills, which estimators must consider. However, sealing ducts or partial replacements may also incur material and labor costs if specified. Option A risks underestimating expenses. Option B may overstate costs if leakage can be repaired rather than full replacement. Option D is premature without assessment. Best estimating practices include modeling increased energy costs and selectively budgeting for repairs or replacements based on leakage severity. Question 15. As demonstrated by recent energy code updates, Estimator must incorporate ventilation effectiveness into his HVAC design for a healthcare facility. How does ventilation effectiveness influence system design? A. It dictates the total volume of air circulated without consideration of air distribution. B. It emphasizes uniform air distribution to reduce stagnant zones and improve indoor air quality. C. It only applies to residential HVAC systems, not commercial or healthcare. D. It allows reducing filtration efficiency in favor of higher airflow rates. Answer. Correct answer. C. Explanation. Ventilation effectiveness is crucial in commercial and healthcare HVAC systems to ensure proper air distribution and contaminant removal. Option A overlooks the quality and placement of air delivery. Option B correctly notes the importance of uniform distribution and avoiding stagnant air, improving occupant health. Option C incorrectly limits applicability to residential systems, healthcare facilities of stringent ventilation requirements. Option D risks indoor air quality degradation. Correct understanding guides system design and compliance. Question 16. Given the circumstances of a complex HVAC retrofit, Smith is developing a bid strategy. She knows that unexpected site conditions may cause delays. What risk management approach should she include in her bid to address this? A. Submit a fixed price bid without allowances for contingencies. B. Include contingency allowances and clearly define scope exclusions in the contract. C. Ignore potential risks to keep the bid competitive. D. Assume the client will cover all unexpected costs separately. Answer. Correct answer. B. Explanation, including contingency allowances and defining exclusions in contracts are industry best practices to mitigate risks from unforeseen site conditions, protecting profitability and clarifying responsibilities. Option A increases financial risk. Option C may lead to losses. Option D assumes client goodwill, which is unreliable. Risk-aware bidding balances competitiveness with protection against uncertainties essential in complex retrofit projects. Question 17. While interpreting architectural drawings, Mr. Lee observes the mechanical room dimensions are tight, potentially complicating equipment installation. How should this influence his equipment selection and cost estimating? A. Choose the largest capacity equipment regardless of space constraints. B. Opt for modular or compact equipment designed for limited spaces, possibly increasing costs. C. Ignore space constraints and focus only on performance specs. D. Delay equipment selection until installation begins. Answer. Correct answer. C. Explanation. Space constraints directly impact equipment selection. Choosing modular or compact units tailored for tight spaces is often necessary, though it may raise costs due to specialized equipment or installation complexity. Option A risks installation failure. Option C ignores practical constraints and risks delays and cost overruns. Option D delays crucial decisions, jeopardizing project timelines. Careful coordination of space and equipment ensures realistic, detailed estimates and smooth project execution. Question 18. From the perspective of safety standards, Mr. Adams must ensure his estimate accounts for OSHA requirements during installation of a high-voltage HVAC control system. What key factor must he consider? A. Safety training costs for personnel and protective equipment must be included in labor costs. B. Safety regulations do not affect cost estimates. C. OSHA compliance is the responsibility of the client, not the contractor. D. Safety standards only apply during commissioning, not installation. Answer. Correct answer. A. Explanation. OSHA safety compliance requires training, equipment, and procedures that add to labor and overhead costs. Including these costs ensures the estimate reflects true project expenses and reduces risk. Options B, C, and D incorrectly downplay contractor responsibilities and cost impacts. Incorporating safety factors is mandatory and essential in comprehensive HVAC estimating and project planning. Question 19. The fundamental question is, how should Mr. Wilson account for equipment efficiency ratings when estimating operational costs for a long-term commercial HVAC contract? A. Use equipment with the lowest upfront cost to reduce initial expenses. B. Incorporate efficiency ratings like here, a few, to estimate energy consumption and operating costs. C. Efficiency ratings have no impact on operational cost estimates. D. Ignore efficiency because all equipment must meet minimum code requirements. Answer. Correct answer. D. Explanation. Efficiency ratings such as EAR and a few directly affect energy consumption and operational costs. Incorporating these ratings in estimates allows for realistic lifecycle cost projections. Option A ignores future expenses. Option C is forces efficiency impacts operating costs significantly. Option D is incorrect. In minimum code compliance is a baseline, but efficiency differences beyond minimum standards can lead to large cost variations. Accurate operational cost estimation requires detailed efficiency considerations. Question 20. Throughout the course of designing an HVAC system, Mr. Gomez evaluates various duct sizing methods. What principle best guides choosing the correct duct size? A. Always use the smallest duct size to save material costs. B. Balance duct velocity, pressure drop, and noise control to optimize system performance. C. Oversize ducts to reduce noise regardless of cost. D. Use the same duct size throughout the system for simplicity. Answer. Correct answer. B. Explanation. Duct sizing must balance velocity, pressure drop, and noise control to ensure system efficiency, occupant comfort, and energy savings. Undersized ducts increase noise and pressure drop. Oversized ducts raise costs and reduce system effectiveness. Option A compromises performance. Option C inflates costs unnecessary. Option D ignores airflow variations and is impractical. Proper sizing reflects HVAC engineering principles critical for cost-effective design and estimation. Question 21. When faced with a bid that specifies the use of variable refrigerant for VRF systems for a mixed-use building, Estimator must estimate installation complexity. What factor most influences the accuracy of his labor and material cost estimate? A. The number of indoor units and their zoning complexity. B. The brand of the VRF system specified. C. The color of the refrigerant piping insulation. D. The size of the building's parking area. Answer. Correct answer. B. Explanation. The specific brand of VRF systems impacts installation complexity due to differences in control systems, refrigerant piping requirements, and training needs. This affects labor hours and material specifications. While zoning also matters, the chosen system brand determines the core installation process. Color of insulation C and parking size D are irrelevant. Accurate estimation requires understanding equipment nuances, including manufacturer-specific installation characteristics. Question 22. The primary reason for including labor productivity factors in cost estimating is A. To account for variations in worker skill, site conditions, and equipment accessibility. B. To standardize labor hours regardless of project complexity. C. To reduce the overall bid price to be more competitive. D. To simplify the estimating process by using fixed hourly rates. Answer. Correct answer. D. Explanation. Labor productivity factors are applied to adjust base labor hours based on real-world conditions like skill levels and site challenges, making estimates realistic and accurate. Option A correctly states the purpose, but D contradicts the reality by oversimplifying estimating. Option B is false because productivity factors vary, not standardize. Option C misrepresents intent. Productivity factors aim for accuracy, not bid reduction. Proper application ensures credible and competitive bids. Question 23. According to recent developments in HVAC load calculation, Estimator notices that infiltration and ventilation loads overlap in certain cases. What is the best way to avoid double counting these loads in manual J calculations? A. Calculate infiltration separately and add ventilation loads on top. B. Use the greater value between infiltration and ventilation loads for each zone. C. Ignore infiltration loads altogether. D. Treat infiltration as part of ventilation loads if ventilation rates are high. Answer. Correct answer. C. Explanation. In manual J, infiltration is typically accounted for within ventilation or envelope assumptions. Double counting by adding infiltration separately when ventilation is already included leads to overestimation. Option A risks double counting. Option B is an incorrect approach to prevent duplication. Option D is closer to correct practice but ignoring infiltration as a separate load when ventilation dominates is more aligned with manual J guidance. Accurate load calculation prevents oversizing. Question 24. In what ways can sheet metal fabrication complexity impact the overall HVAC system estimate as Singh reviews? A custom ductwork scope. A. Complexity primarily affects fabrication lead time, not cost. B. Increased complexity raises material waste, fabrication labor, and tooling expenses. C. Complexity has negligible impact as standard fabrication rates apply. D. Complexity only affects on-site installation, not the initial estimate. Answer. Correct answer. D. Explanation. Sheet metal complexity significantly affects material waste, labor hours, and tooling, all of which increase costs upfront. Option A ignores cost impact. Option B accurately identifies key cost drivers. Option C is inaccurate because standard rates do not cover unique fabrication challenges. Option D misplaces complexity impact, which affects fabrication more than installation. Recognizing these factors leads to comprehensive, realistic HVAC system estimates. Question 25. Based on the information available, Mr. Lewis is calculating the heating load for a commercial space with large glass facades. How does window U-value affect the heating load? A. A high U-value increases heat loss, raising heating load requirements. B. Window U-value does not affect heating load, only cooling load. C. Low U-value windows result in increased heat loss. D. U-value is only relevant for insulation, not windows. Answer. Correct answer. A. Explanation. U-value measures thermal transmittance. The high U-values mean more heat loss through windows, increasing heating loads. Option B is incorrect because U-value affects both heating and cooling. Option C reverses the relationship. The lower U-values improve insulation, reducing heat loss. Option D incorrectly separates U-value from windows where it is critical. Accurate heating load calculations must include window U-values to size equipment properly. Question 26. While interpreting HVAC project specifications, Ramirez notes that the bid documents require adherence to NFPA electrical standards for unit connections. How should this influence her estimating process? A. Add costs for specialized electrical components and qualified labor. B. Assume all electrical work is standard and requires no special considerations. C. Exclude electrical work from the estimate since it's the electrician's responsibility. D. Apply flat fee for all electrical requirements regardless of scope. Answer. Correct answer. C. Explanation. Electrical work compliance with NFPA standards often requires specialized materials and trained labor, impacting cost and scheduling. Ignoring these factors by excluding electrical scope risks underestimating. Option A reflects proper estimating practice. Option B assumes no additional cost, which is unsafe. Option D oversimplifies diverse electrical requirements. Accurate HVAC estimating includes coordination with electrical trades and relevant standards to produce thorough, realistic bids. Question 27. When calculating duct pressure drop for an HVAC system, which parameter most critically affects the selection of duct size to balance system performance and cost? A. Airflow velocity and friction losses within the ductwork. B. The total length of the duct runs only. C. The color of the duct insulation. D. The brand of the duct material supplier. Answer. Correct answer. A. Explanation. Duct pressure drop depends primarily on airflow velocity and friction losses. These factors drive duct sizing to achieve required airflow without excessive noise or energy use. Total length. B. Affects pressure loss but is only part of the equation. Color. C. And supplier brand. D. Do not influence pressure drop. Proper duct sizing balances velocity and friction to optimize cost, comfort, and energy efficiency for effective estimation. Question 20. To better understand labor estimating for HVAC installation, Mr. Thomas considers site-specific factors. Which factor most directly increases labor hours and cost? A. Restricted site access and congested work areas. B. Availability of off-the-shelf components. C. The supplier's location relative to the site. D. The weather forecast on installation days. Answer. Correct answer. B. Explanation. Restricted site access and cramped conditions directly increase labor time by complicating equipment handling and movement. Option A correctly identifies this. Availability of components. B. Affects procurement, not labor. Supplier proximity. C. Impacts logistics, but not on-site labor. Weather. D. Can cause delays, but does not consistently increase labor hours. Accurate labor estimating must consider site constraints to avoid budget overruns. Question 29. In summary of energy codes affecting HVAC system design, how should Mr. Allen incorporate energy efficiency requirements into his estimate? A. Include costs for energy-efficient equipment and controls exceeding minimum standards. B. Only use the minimum efficiency equipment allowed by code to reduce upfront costs. C. Assume energy codes do not affect cost estimating. D. Exclude controls from efficiency considerations. Answer. Correct answer. C. Explanation. Energy codes often require higher efficiency equipment and advanced controls that increase upfront costs but reduce operational expenses. Option A is the best practice to reflect true project requirements. Option B ignores long-term code compliance risks. Option C neglects the impact of codes on design and cost. Option D misses that controls significantly affect energy use. Integrating energy efficiency requirements is crucial for accurate and compliant HVAC cost estimating. Question 30. When evaluating bid documents, Stewart finds ambiguous language about allowance for system commissioning. How should she handle this uncertainty in her estimate? A. Exclude commissioning costs as they are not clearly specified. B. Include a reasonable allowance based on similar past projects and clarify scope in bid notes. C. Assume commissioning is the owner's responsibility and exclude costs. D. Add a large contingency without explanation. Answer. Correct answer. A. Explanation. Commissioning is a critical phase ensuring system performance and omitting it risks underestimating project costs and scope. Option B represents best practice by including allowances and clarifying scope. Option A risks cost overruns by ignoring an important task. Option C may be inaccurate if commissioning is part of contractor scope. Option D lacks justification and reduces estimate credibility. Proper allowance ensures comprehensive, transparent bids.